Engineers use 3D modeling to simulate every bolt and wire of the Boeing 787 Dreamliner. The final turbines. The Dreamlifter carries prefabricated sections of the Boeing 787 Dreamliner from Japan and Italy. Specialized loaders, automated tape layers build the carbon fiber fuselage layer by layer. This composite structure is significantly lighter than aluminum, making the Dreamliner far more fuel efficient. Under immense heat and pressure, the resin cures, creating a single-piece barrel without rivets. The process is complete as the sensors cool.
Safety is the top priority for the Boeing 787 Dreamliner, and even a microscopic flaw would lead to the section being scrapped.
Fly-by-wire interface is secure, initiating final diagnostic sequence now. The center wing box is the strongest part of the 787 Dreamliner. Robotic machines drill perfect holes for titanium fasteners before it moves to the assembly line. The rudder and stabilizers are securely attached to the rear fuselage. Aerodynamic testing confirms the shape and
This is the moving line concept. Using laser-guided alignment, the nose, middle, and tail sections are brought together with sub-millimeter precision.
For the Boeing 787 Dreamliner, these joins must be airtight to maintain cabin pressure at 40,000 feet.
These lightweight carbon fiber beams provide skeletal strength. Precision leveling is critical to ensure the floor is perfectly level. These titanium pipes form the 787 Dreamliner's 5,000 PI hydraulic system, ensuring faster response for the flight surface. Unlike older planes, the Boeing 787 Dreamliner is more electric, replacing many pneumatic systems with electrical ones.
The green insulation blankets regulate the temperature and reduce engine noise for a quiet 787 cabin. The material
drive. The massive overhead cranes guide the Dreamliner wings into place, highlighting the paddle fittings. The wings flexibles. The vertical stabilizers is lowered, ensuring precise aerodynamic alignment of the rudder. This design reduces drag, as the actuators extend, the elevators move down for pitch control, demonstrated here during the dry swing test procedure.
Initiate lowering sequence.
Sequence active. Watching the struts.
Weight on wheels confirmed. Systems check complete.
The carbon brake discs and anti-skid sensors modulate pressure rapidly. This prevents skidding on icy surfaces or during.
The Boeing 787 Dreamliner takes fresh air from the outside, rather than using engine bleed air, making the cabin air cleaner.
The auxiliary power unit provides electricity and air when the main engines are off.
The complex hinge mechanism is designed to create a perfect seal during the automated door slam test.
The wet wing design means the structure holds the fuel. Technicians apply sealant and install spark-proof sensors before. With the touch of a button, the Dreamliner's electrochromic windows instantly transition from clear to a deep, dark blue tint, optimizing cabin ambiance.
The pylons hold the massive engines of the Boeing 787 Dreamliner. These vibration-dampening mounts are critical components.
The arrival of the GE and Rolls-Royce engines highlights the technology race. Notice the chevron shapes, key to the Dreamliner's quiet performance.
The quick engine change features allow for rapid maintenance. As the engine meets the pylon, the main fuel and data lines are.
Advanced composite materials and specialized thermal acoustic insulation work together to resist extreme engine heat, ensuring optimal performance and safety. Utilizing an advanced kinematic mechanism, these larger pivoting bins close effortlessly. Custom interval. Utilizing lightweight composites, the assembly team meticulously installs the complex wiring harnesses for the in-flight entertainment. The Boeing 787's modular cabin design allows teams to quickly reconfigure the layout by bolting seats directly. These modular units utilize a highly efficient waste management system, minimizing space while maximizing hygiene. The central server system is the backbone of the in-flight entertainment, delivering high-definition movies and games directly to every seatback screen.
The newly installed LED system dynamically shifts colors, mimicking sunrise, sunset, and starlight to
Our antenna connects directly to the satellite network,
bringing high-speed Wi-Fi through these access points to every passenger.
Here. Emergency oxygen masks, life vests, and exit slides must meet strict certifications like TSOC. To protect critical areas from paint, teams meticulously mask the Dreamliner. The precision required for sensors and windows is paramount. The meticulous sanding ensures a perfectly smooth surface, crucial for aerodynamics and optimal paint adhesion.
The electrostatic painting process ensures an ultra-thin, even coat. On the Dreamliner, every gram of weight
Glides. This specialized team uses intricate stencils and multiple layers of paint, demonstrating the precision and artistry required. Strict compliance with aviation regulations means every detail, from no-step warnings to registration numbers, must be flawlessly applied and inspected.
Applied by robotic arms, this clear coat provides critical protection against UV radiation.
Initiating light test sequence, strobes activating.
Navigation lights check, green and red steady, landing lights on.
Systems nominal, test complete.
As the radome is secured, the integrated weather radar activates, scanning the skies to provide pilots with critical data for avoiding severe weather. The pitot tubes and static ports provide crucial airspeed and altitude data. Here, a technician ensures they are free from obstruction before flight.
We're activating the hydraulic systems now. The 787 features triple redundancy in its hydraulics, powering the landing gear.
Initiating max load test on generators.
Monitoring power distribution stabilization. Looking good.
Affirmative. Systems check complete. Simulating full flight power draw.
Computers continuously monitor and adjust the flight surfaces, translating pilot commands into precise movements for perfect control. The triple redundant architecture ensures accuracy. Watch the synchronization across all three channels.
Confirmed. Signal lock achieved.
This maneuver, known as a rejected takeoff, rigorously tests the aircraft's steering, brakes, and landing gear under the most realistic conditions.
This is a critical safety check of the 787 Dreamliner's emergency systems, ensuring the rapid and reliable deployment of the evacuation slide.
This is the final human eye check for any imperfection before flight.
Pressure stabilization looks good on section 7.
Agreed. The bird is ready. It's time to fly. And there she goes, the 787 Dreamliner, carrying the hopes and the immense fears.
Pilots intentionally induce vibrations during flutter tests. The wings shake, but the flexible design dampens these airspeed decaying, buffeting.
Stall, max power, nose down, push.
Speed increasing, recovering.
Fly-by-wire electronic flight controls use multiple computers for flight envelope protection and load alleviation. Ensure
Faced with 50-knot crosswinds, the pilots demonstrate incredible skill, grabbing the massive 787 sideways before perfectly aligning for a safe
The Boeing 787 Dreamliner must demonstrate it can stop safely from takeoff speed without the brakes catching fire.
This proves the Boeing 787 Dreamliner's engines won't flame out during heavy rain or flooding. Millions of volts strike the fuselage, but the embedded copper mesh safely conducts the electricity around the cabin, dissipating the charge harmlessly. The 787's composite fuselage eliminates the corrosion risks of aluminum, allowing cabin humidity to be maintained at a...
We're pushing thousands of commands simultaneously. The system load is critical, but stability holds.
The chevrons on the engine nacelles mix the hot exhaust gases with the cooler ambient air more efficiently, dramatically reducing the noise generated. Every hour of flight requires hundreds of hours of data analysis. The results are clear. The engines have a clean bill of health. From the cockpit to the galley, our specialized cleaning agents make the 787 Dreamliner spotless. We take pride in that new plane smell. Sensors. Even a Boeing 787 Dreamliner needs a perfect backup.
We calculate the empty weight to determine the precise center of gravity, which is critical for fuel efficiency.
Without this certificate of airworthiness, the Boeing 787 Dreamliner cannot carry passengers.
As you can see, these coffee makers, ovens, and trolleys are all customized specifically for the airline's catering needs.
Okay, powering down the suction arm.
Panel secure. Looks flawless.
Finishing up the seam right here.
Utilizing pressure pack technology, the specialized team secures the compressed slide unit. The door is then closed and armed, ready for operation.
These contain every detail of how to fly and fix the Boeing 787 Dreamliner.
She handles like a dream. The test flight was a complete success.
Fantastic news, Captain. Congratulations to the whole team.
The high-speed aerodynamic wax creates a super smooth, glass-like finish, reducing drag by nearly 2%. This shape.
Okay, hold it right there. Brakes on. Copy that. Setting the brakes now. Clear to disconnect.
The Dreamliner is officially yours.
Thank you. We look forward to putting her into service.
I can't believe it's finally ours. Look at this view. It's incredible.
All right, calm down, everyone. Radio check, 1, 2.
For the Boeing 787 Dreamliner, a single tank can last over 15 hours of flight.
This is a ferry flight, meaning the Boeing 787 is flying empty, without passengers, as it heads towards its new home base. The Boeing 787 Dreamliner features laminar flow technology on these engine cowlings, significantly reducing drag.
The registration is updated to GLNCR, replacing the previous N number.
Very good. All checks are complete. Here is your certificate of airworthiness.
Welcome to the inaugural flight. Enjoy the sky interior.
This is amazing. Look how spacious it is.
Live telemetry streams directly from the Dreamliner. The system analyzes performance metrics,
engine parameters and oil filters checked. Everything looks good.
Avionics sensors confirmed operational. The Dreamliner is cleared for the next mission.
Confirmed. Keeping the exterior of the Boeing 787 Dreamliner clean significantly reduces drag during flight, contributing directly to optimal fuel efficiency.
Utilizing active gust suppression, the Boeing 787 automatically adjusts control surfaces like the ailerons and rudder.
50, 40, 30.
Checked, airspeed steady.
20, 10, retard.
Landing gear down, thrust reversers engaged.
The Boeing 787 Dreamliner is not just a passenger plane, but also a vital cargo lifter.
The plan details how we're closing the loop on the 787 Dreamliner. By recycling carbon fiber, we're creating a sustainable...
A side-by-side comparison reveals the differences in length and passenger capacity across the three 787 Dreamliner models, all built on the same architecture.
The Dreamliner is a platform for innovation, leading to the next generation of sustainable flight technology.
The Boeing 787 Dreamliner, fulfilling the long-range point-to-point mission, connecting cities that were once worlds apart.
In a high-fidelity simulator, pilots routinely turn action out precisely. This rigorous world
just landed on the Boeing 787, feeling surprisingly refreshed.
I slept the whole way. The cabin air is amazing. I'm ready to explore.
The Boeing 787 Dreamliner provided a pathway to profitability. By opening new routes and lowering operating costs.
To the Dreamliner, millions of safe flying hours.
The Boeing 787 Dreamliner, not just a machine, but the future of human connection.